Okay, I'm going to be solving quiz number 18 for calculus 1000. For the function f defined below, prove whether or not the function is differentiable at x equals 1. If it is differentiable at x equals 1, then state what f prime at 1 equals. Okay, before we tackle this problem, there are two important facts that we must pull out from the problem in order to make it more easy to solve. So first, it wants us to figure out whether or not the function is differentiable at x equals 1. So underline that. And if it is differentiable at x equals 1, it wants us to find f prime of 1, or basically the slope at that point. So now we're going to move on to our two functions which make up our piecewise function. And this basically just describes what's happening at the left of x equals 1 and to the right of x equals 1. So the first thing that we're going to want to do to find whether or not our function is differentiable is to find the limit at the point x equals 1. So here I have our piecewise function broken up into its two parts. And what we're going to do basically for the first one is find the limit as x approaches 1 from the left. And to do that, all we're going to do is plug in 1 for everywhere we see x. And then we're going to evaluate, and that equals 3. And we're going to do the same thing for the limit as x approaches 1 from the right. So wherever we see x, we plug in 1, and that also equals 3. So now we have these two functions. We found the limit for them at x equals 1, and because both y values are equal, we know that our function does have a limit at x equals 1. So that satisfies the first part of the question, and now we're going to see what f prime at 1 is equal to. So we're going to use our definition of a limit to figure this out. And basically, what we do is use our definition in order to evaluate what f prime at 1 is equal to. So you're going to plug in x plus h for everywhere you see x. And then you're just going to have your regular f of x. And sorry, I didn't write this at the top. This is 3x squared. And this is all over h. And now I'm going to FOIL this out and distribute the 3. And from that, I get 3x squared plus 6hx plus 3h squared minus 3x squared. And then we're going to put that all over h. And as you can see, we're going to combine like terms, and these two cross out because one is positive and the other is negative. And next we're going to factor out our h and have our 6x plus 3h. And we factor out an h so that we can also cross out the bottom h, because if not, when we plug in 0 back into the h's, this will make our limit undefined, and we don't want that. And now we're just going to plug in what we know. And we know that we're evaluating the limit at x equals 1. And we know that h equals 0. And when you evaluate this, you get 6. So that is for the left side of the function. And then we're going to go over and do the right side. Same process. 2x to the third plus 1. And then we're going to plug in x plus h wherever we see an x plus 1, and then minus the function, remember to distribute the negative sign. So this is going to be a negative 2x to the third minus 1. And then we're going to factor and distribute out the 2. And that equals, oh my god, 2x to the third plus 6x squared h plus 6xh squared plus 2h to the third. And then you can go ahead and bring down your plus 1 and your minus 2x to the third minus 1 all over h. And then we're just going to simplify by combining like terms. And these cross out because they're positive and negative of each other. And then we're going to factor out the h because we want something that we can use to cross out this h at the bottom, remember. So we have 6x squared plus 6xh plus 2h squared all over h. And now we have a way for our two h's to cross out. And then we just plug in what we know. X equals 1, so this equals that. And h is 0. Sorry. H is 0. And 2. Then that is also 0. And when we evaluate this, this makes everything 0. This makes everything 0. And so the answer is 6. And so for our question again asks if it was differentiable at x equals 1. We proved that it was because the limit of the function was 3. And then we found what f prime at 1 equals, which is 6. And that's the end of the problem. Goodbye.